Hello, uh, I'm here to present unto you a question on the issues to do with resistance. Welcome. May you find this one being of help unto you. Thank you so much. Welcome. So you're told in the figure we shall be having the question as the figure below: a battery of electromotive force 6 volts and negligible internal resistance is connected to an arrangement of resistors. The potential difference across the 16 volts is 4 volts. So here is the diagram where you have been told the EMF for the whole system is 6 volts. Then you've been told that the potential difference across the 16 ohm resistor will be 4. So the PD here is 4. And then your asked determine the current through the 16 ohm resistor. So the first thing is you need to analyze the diagram. So you can see we are having a certain connection here. We have the 12 and the R ohms which are in parallel, and then the resultant resistance is now in series with 16 ohms. So now if we start handling question 1, then we'll say that from Ohm's law we know that V is equals to IR, and therefore our voltage here is at 4. So 4 is equals to the current that is in the question times R, which is 16 ohms. So our current becomes 4 divided by 16. Mathematically this becomes a quarter, and this is equivalent to 0.25 amperes. Equivalent to 0.25 amperes. Then now the next question, you are told to find the value of R. You are told to find the value of R. So how do we get R? The first thing that you need to understand is that if we have a PD of 4 volts here, then the remaining voltage will be distributed here. Why? Because we say that voltage in series is shared, voltage in series is shared. Voltage in series, you can say voltage is shared, but the current is the same. So what do we do about it? So from the total of 6, so the remaining, which will be our 2 volts, will come to be at this point. So now we have to first look a way of getting the effective resistance for the whole system. So we can analyze and say that, let me push this question here. So that we can have a common place where we'll be able to keep following up. So now the value of R, then you need to analyze and say that we have a V of the voltage here, which you have got is of 2 volts, and the current in this case will be 0.25 amperes. Why? Because you have said the current will be the same. So the current at 16 ohms will be the current add across the 12 and R combined. And then now resistance. How do we find resistance in the parallel? Since they are only 2, we'll say it is 12 times R over 12 plus R. And now from the Ohm's law, where V is given as IR, then our 2 volts will be the same as 0.25 times the combined resistance, which will be 12R over 12 plus R. So what will this one bring unto us? So if we divide through by 0.25, then we shall be having divide by 0.25 across, then we shall be having a 2 out of 0.25 is equals to 12R over 12 plus R. So this one will lead us to 0.25 times 12, this one times 12 if we cross multiply. So let me start with the 2. So this one will be the same as 2 into 12 plus R is equals to 0.25 into 12R. So this becomes 24 plus 2R is equals to 0.25 is like a quarter of. So a quarter of 12 becomes 3R. So now you need to make R the subject of the formula. So we take our R, the 2R there. So it becomes 24 is equals to 3R minus 2R. So our R becomes 24 ohms, like that. It becomes 24 ohms. That gives us the value of R. So maybe we can add our own question where we can say, now the effective resistance, this will be, for the one that is in parallel, it will be 12. So we start with the parallel. It will be R1, which is now 12, times R2, which is now 24, divided by 12 plus 24. What does this one lead us to? (24) times 12, that is 288. So we have 288 on top divided by 36. So divided by, answer divided by 36, and this gives us 8. So we have 8 ohms for the parallel one. Then now RT will be now 16 plus 8, arrive at 24 ohms. If you find this information being of help, kindly keep sharing with others. May God bless you. Don't forget to subscribe, leave a comment, like, and also share to others. Thank you.